Now, what happens when we don't have trig in the problem, but the integral looks a little familiar to us, all right? Well, here we have an integral. We've got an x squared, and we've got the square root of 9 minus x squared. So this 1 over square root of 9 minus x squared should look a little familiar. That reminds us of the derivative of arc sine, okay? And so that leads us to think about our right triangle here. And let's think about this situation here. If we have sine of an angle is u over a, we could say u is a sine theta. All right, so this means we have an angle that has a sine of u over a. And with that, we can use Pythagorean theorem. We get the square root of a squared minus u squared. Okay, well, we can use this triangle. We can say, well, the cosine is square root of a squared minus u squared over a. Okay, or we could rearrange this to say the square root of a squared minus u squared is a cosine theta. Okay. If we involve tangent here, okay, tangent is u over a. Well, we get this triangle here. Okay, now you can pause and give it a try. See if you can fill in the rest here. Find this as a square root. Find the secant. Try this third one here. All right. Well, it's going to be the square root of a squared plus u squared. So that means the secant, which is the reciprocal of cosine, the secant is the square root of a squared plus u squared all over a. And if we multiply both sides by a, there we get the square root of a squared plus u squared is a secant theta. All right. And what if we start with secant? Well, if we start with secant, the secant is u over a, so that gives us this triangle. Well, using the Pythagorean theorem, we get this as the square root of the hypotenuse squared, u squared minus a squared. So the tangent of this is the square root of u squared minus a squared all over a. And if we multiply both sides by a, we get the square root of u squared minus a squared. So what did we just find out? Well, here, we'll consider u to be an expression involving x usually, and a to be a constant. So in all these expressions here, u is something involving x, and a is a constant. Okay? And so we have these relationships here. Sine led to cosine. Tangent leads us to secant, and secant leads us to tangent. Okay, they're connected in that way. So here's some key strategies, all right? So if we have an integral with an expression in one of these forms, where a is a function of u, a is a constant and u is a function of x, then we can make a right triangle that produces the given form. We can use a trig function of theta to evaluate the integral. And then we can use the triangle to substitute for theta in the end. All right, so we're going to convert it to theta, and we'll bring it back to x. All right? Okay, let's see how that works. All right, so here we have an integral. Now, this gives us a little hint here. We want to use x equals a sine theta. All right, so notice we have 9 minus x squared. So that fits this model right here. Okay, so we need to make a triangle that ends up with a side 9 minus x squared. Well, what's that triangle? Let's go ahead and do that. Here's our triangle, right triangle. I'm going to draw it out. So we have x over 3. And if we use the Pythagorean theorem, we get 9 minus x squared for this third side here. All right? So now, and we got our angle theta here. So now we need an expression that involves this here, okay? That involves this expression with an x and this 3. So, all right, so that would be the cosine. So the cosine of theta is the square root of 9 minus x squared all over 3. Or if we multiply both sides by 3, 3 cosine theta equals the square root of 9 minus x squared. All right, good. Well, we're all ready to substitute here. Okay. We have this expression here, which we can say 3 sine theta equals x. Oops, x. And we're going to need one more. So we're ready. We can substitute for x. We can substitute for the square root there. But we need to also substitute for the dx. We're going to change everything here into thetas. So let's get one more. We need an expression for d theta. So here we have a function of x. So we can say dx, d theta, the derivative of x with respect to theta is, well, derivative of 3 sine is 3 cosine theta. Okay. And so if we multiply both sides by d theta, dx is 3 cosine theta d theta. Okay? So now we are ready for our substitutions. We've got these 3 things here to substitute for. All right, here comes our trig substitution. So that is just kind of all kind of in preparation there. Okay, so now we're ready to substitute. Dx is 3 cosine theta d theta. We said x was 3 sine theta, so we're going to replace that with 3 sine theta squared. Don't forget this little squared there. And this square root there, whoops, this square root is 3 cosine theta. So this is 3 cosine theta. All right. A little bit of cleanup here. That cosine cancels with that cosine. That 3 cancels with that 3. And we end up with the integral of 1 over 3 squared is 9 sine squared theta d theta. All right, now we can pull out that 1/9. And 1 over sine squared is cosecant squared. And you remember what what function has a derivative of cosecant squared? Well, that is cotangent. So this is cotangent theta plus c. Now this is in terms of theta, but we want in terms of x. So we remember our SOHCAHTOA. SOHCAHTOA. All right, tangent is opposite over adjacent. So looking back at our triangle, cotangent is the reciprocal of that, adjacent over opposite. So we end up with 1/9 times the adjacent, which is the square root of 9 minus x squared, over the opposite, which is x. So square root of 9 minus x squared all over 9x. There you have it. Don't forget your plus c. Okay, so that's how it works. So again, big idea. We changed it into thetas, and then we did our integral, and then we change it back in the end. All right, let's try a little more here. A couple more quick examples. Here we want to use a tangent theta. All right, so this is giving us a hint that tan theta is going to be x over a, or some version of that. Okay, so we wanted to find our tangent, and the key there is this plus. That's showing you that's our hint there. So, well, we're going to square root this. If we square root this, we get 2x, and we square root this, and we get 1. All right, so that means we're going to want to have 2x and 1 will be our square rooted versions there. Okay, so this is theta, and so this is the square root of 4x squared plus 1 squared, which is 1. So now we have that. Okay, so we're all ready to say, all right, the tangent of theta is, in this case, 2x over 1. Okay, we're going to need a function, or a trig function involving this. Okay, so, well, cosine is 1 over this, And we want this on top, so we want secant. And yes, tangent and secant will go together because they're derivatives of each other. They're related by derivatives. Square root of 4x squared plus 1 over 1. Multiply both sides by 1. In other words, it just goes away. And we have secant of theta is the square roots of, what is the square root of 4x squared plus 1? All right. We need to get a dx here, so we'll use this to get our dx. Okay, so if we got tangent theta equals 2x, so if we divide by 2, we got 1/2 tangent theta equals x. And so dx d theta, the root of tangent is secant squared. So this is 1/2 secant squared theta. Okay, so we can say dx is 1/2 secant squared theta d theta. All right. Great. So we've got our dx, so we can do a bunch of substitution here. Okay, so we're going to substitute for dx. So we got the integral of 1/2 secant squared theta d theta. So we used this substitution here. And now we have this expression, which we got right here. That's just secant theta. So divided by secant of theta. Well, this is going to simplify nicely, huh? That 1/2 can come on outside. One of these cancels with one of those. And we have 1/2 integral of secant theta d theta. So this is one we can look up and use our table for this. So looking this up in our trig tables, we end up with 1/2 times the natural log of secant theta plus tangent theta plus c. And don't forget to convert this back. So we got 1/2 times the natural log of secant theta, which was the square root of 4x squared plus 1. That comes from here. And then tangent theta is 2x. So plus tangent theta. Nope, I'm sorry. Plus 2x. There we go. We want it in x's. Plus c. There you go. So I got a couple more here. So we have rational exponents here. So remember that if we have something to the 3/2 power here, this means we have the square root of x squared plus 1 to the third power. All right, so we have x squared plus 1. So notice that it's a plus. That means we're going to want to use tangent here. So we're going to make our triangle with our theta. And we want an x and a 1. So we're saying that the tangent of theta is x over 1, or just x. And so this is the square root of x squared plus 1. So now we can say this is the secant. Secant is the inverse of cosine. So we can see the secant of theta is the square root of x squared plus 1 over 1. But we don't really need the over 1 there, so we'll just leave it at that. Great. Well, now we can substitute here. Almost. We need one more thing. We need our derivative. dy dx, or dx d theta, actually, we should say, is derivative of tangent is secant squared, right? That's convenient. So secant squared theta d theta equals dx. So now we can do our substitution. So we can rewrite this as secant squared theta d theta. So we replaced dx with d theta, or secant squared d theta. All right. Then we've got this thing right here. Let's see if we can get a highlighter to work here. Right there. So we have secant. Pins are doing crazy things here. Secant theta cubed. All right, which also is just secant cubed. That means that's what that means. So secant squared theta over secant cubed theta. That's what that means. You don't have to write this out necessarily, but that's what it means. And, well, this can be simplified. And we just have the integral of 1 over secant theta d theta. Well, what is 1 over secant? 1 over secant is the reciprocal of secant, which is cosine of theta. And we know that that is sine theta plus c. Are we done? Not quite. All right. So we need to substitute here. We need this in terms of x. So we got to come over here. What is the sine of theta? Well, the sine of theta is opposite over hypotenuse, x over the square root of x squared plus 1. So we're going to swap that out. Sine theta is x over the square root of x squared plus 1 plus c. There you have it. Okay? Don't forget to take it back to x's in the end. All right, well, we'll leave it at that. So the main steps here is we need to build this triangle. And from that triangle, we need to define a tangent or sine or cosine that will give us the square root we're looking for. And then we need to define these terms here. We need an x to be defined so we can find dx. And we also need to have a trig function that is equal to that square root so we can do the substitution. All right, well, those are the main things we're looking for. So it can definitely be challenging. These little shortcuts can kind of help. If we have this form, we'll be using a sine. If we have this form with a plus, we'll be using a tangent. And if we have this form with a minus, we'll be using a secant. So those are kind of the keys that we're looking for there. All right, thanks a lot.